Okay, so today we're going to look at the cutout spot in a frame. So this would be either on fuselage or let's say on top of a wing and so on, so on. So let's write over here the aircraft structure is continually faced with requirements, and I will mention a few cases now, for openings in panels / webs to provide so let's say the most general would be to create access. So what could be the access would be to create access for maintenance. So let's say electronics, hydraulics, okay, and the other one would be to create also like let's say windows, doors, and etc. Okay, so this is just common sense, but the two most general ways to provide cutouts would be what? Let's say here would be A, suitable framing members, and that's personally my favorite one. Okay, I mean, it's to use common sense. So let's say you have a aircraft structure over here, all right, and let's say, okay, so there will be two flanges over here, and let's try to divide this in 3. Okay, so it would be just a section, all right? So let's say you want to create an opening here. So the best thing is to create the frame here, some stiffeners, okay? And the best way is just to create here cutout okay, in a section, but that is to run them by stiffeners on both directions. Okay, and the other one is to provide some so it's called doubler we just got it that way, and this time just imagine you have a similar panel as this one. Okay, but this time you don't want to provide additional weight by adding stiffeners. So let's say maybe there is not much loading, so what you can do is just to create here Alright, so this is your cutout over here. You just add around your cutout, let's say you put additional material. Okay, so let's say this is the stiffener over here, let's say. This would be like rivets, so you can put another structure here with rivets to reinforce the area of the cut. Okay, so let's do an example. I probably do for this one. All right. So let's see, page 39 will be an example. And the example will be for framing cutout. Okay, so let's just do a similar sketch that we had before, but I have to put some dimensions. So let's say this is one flange or one spar. Okay, and like many times in aerospace structure, you cannot study the whole structure, so you just need to study one section of it. So you see this is our spar that is subjected to some type of
Sorry,
bending.
I didn't quite catch that. Could you please repeat it?
And so this load over here, let's say we'll have here. So let's say the top will be in compression. So at the bottom will be in tension. Okay, so let's say it will be P1, P1, so it will be P2, P2. Okay, so obviously I need to put different forces so that then there is a shear flow, because if it's the same force, that would mean that, it will be in static equilibrium. So if this is this way, this will mean this will bend like, let's say, up, okay? So at this side will be in compression and this side will be in tension. So the top will be in compression. And the lower part would be in tension. So in other words, this is bending like this way, okay? All right, so now we want to create a cut. So let's try to divide this in 3 again. So let's maybe frame it over here. All right, so we need to divide this 1, 2, 3. So here, 1, 2, and 3. Okay. So this would be our original structure. All those little points like simulate rivets. Okay, let's want to create a cutout here in the middle. So let's say we're gonna add here a frame. A stiffener. So let's add one over here and another one here. Okay, so that now we can create the opening, or our cutout will be right over here. Okay, just imagine it's a window. That's basically what I'm trying to sketch over here. So this would be here your cutout. Okay. So now let's try to put some dimensions. So let's say from here to here to here to here. Each one will be 12 inches, 12 inches, 12 inches. Now that distance over here will be 5 inches, so let's do symmetric, so this one will be as well 5 inches, and the one in the middle will be 7 inches. Okay, so over here, due to this load, this is going to create a shear force going over here. Let's say this will be Q sub naught, so on the other side should be going down. And this would be the other Q sub naught. Okay. So in this problem, we're going to assume that Q sub naught is given. Okay. Otherwise, what will be really Q? Okay, let's say this is subjected to a shear force. I mean, you can calculate it, but let's say if due to bending, which is the case over here, generally the shear force would be, the shear flow would be equal to whatever is the shear force going throughout this cross section. All right. So shear divided by depth. So in this case would be the force, and the depth would be from here to here. So it would be the force going throughout all that distance. Okay. All right. So that's generally the way Q sub naught is calculated. All right. So let's go. So we're going to solve what will be the shear flows on each one of these panels, and as well we're going to find what will be the load on the flanges and the stiffeners, as we did over the other problems. So the method over here is pretty simple. What we're going to do is that this is Q sub naught, so each panel should have a Q sub naught shear flow. Okay? So now imagine that you put now shear flow here, which is equal to minus Q sub naught. So that will mean that when you do the calculation, it will remove the shear flow in that one over here. And that's going to result for different shear flows by symmetry. You will have this one, this one, this one, this one should be the same. And then this one will be the same. And this one will be the same. Okay, so the first thing to do is under procedure. So procedure will be in red. First is to assume a shear flow Q sub naught. So let's say Q sub dot bar equal to minus Q sub naught at the cutout panel. Okay, 2 will be to find the shear flows surrounding the cutout panel. Okay, by considering the equilibrium of the stiffeners and so on. And finally, let me remove this. Okay, and finally, step 3 would be to calculate or determine actual loads on flanges and stiffeners. Okay. Okay, so let us do the first procedure over here. Okay, the first step. Alright, so page 40. I'm going to simplify the notation, so it will be step 1. Alright. This one here, but this is, I will cut. This is divided by 3. Okay, I could have done a better job, and let's say we are here P1, P1, P2, P2, and we say we're going to have the shear flow, so let's assume this one here, let's say we'll do one positive here. So we have this, then we're going to have this, and we're going to have this, so this will be Q sub naught. Okay, so on the original panel, what we'll have is, okay, let's do this in detail. So let's see what will happen to the panel if it was not cut out. So this is what you will have basically in every single panel. Okay, you have this, 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 this. Okay, now we're gonna have this over here. Let me just close it now. Down over there, down over there, down to the left, down to the left. Okay, so now what happens if we remove this panel? Okay, so this will be for no cutout. Okay, so what we need to do now is with the cutout, okay, so with the cutout, we're still gonna have here the so now what's gonna happen, we're gonna assume over here over here we're gonna put the, so let's say this would be cut out. So the cutout, we assume a shear flow which is opposite to this one. Okay, so that will mean what? That our Q sub naught bar equal negative Q sub naught basically would just be in that direction here. Up, down, and here would be positive. And this one you put it over here, so what's gonna happen is that this one will be 0, and then we're gonna have on this side Q sub 1, Q sub 1, Q sub 1, Q sub 1. Okay, by symmetry. And then All right. And then over here, now you will have here and here you will have, let's say, a Q sub 2, and by symmetry will be here the same. Okay, and we can do the same figure over here. Okay, and finally, you will have another shear over here. Let's say that would be Q3. Okay, it would just be as the other ones over here. Okay, so now we need to determine what will be Q1, Q2, and Q3. So this is with cutout. Okay, we need to determine Q1, Q2, and Q3. Okay, so this will be step number 2. So step 1 was to assume Q sub naught bar equal to minus Q sub naught in the cutout panel, so we have 0 over here. And now we need to determine how this will affect the shear flows over here, Q1, Q2, and Q3. So now we need to find here Q1, Q2, and Q3. Okay, and this is done just by looking here at those stiffness. So maybe let me do some numbering over here. This will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. Okay, so always like on the previous problem, we need to find, we know Q sub naught. That is all the one over here and all over here. Okay, so let's first look at the stiffness that are like on top. Then we can look at this one or this one. We'll see. Let's start at the top one. So let's first look at the flange. One, 2, 3, and 4. Okay. So if I look at that one, I just do the sketch over here. So let's say this will be 1, 2, 3, and 4. 2, 3, 4. This over here to see that is some over here, so we know that over here we're gonna have look over here, Q1. Here I'm gonna have Q2, and here I'm gonna have again Q1, and all this is resisting what? The here P2 minus P1 that we know would be equal to what? On shear flow should be equal to this one, because the same one you have this one going up, this one going down, you will have here a Q sub naught, and here another Q sub naught. Okay, going to do the complete figure. So then on top over here you're gonna have, so if I put it this way, you're gonna have in those 3 sections you're gonna have Q sub naught, Q sub naught, and Q sub naught. Okay, and we know the distances between each ones of these ones is what? Oops, that's not the page, it's this one. So it's 12, 12, and 12. Okay, all of them are 12. So I do on this line, and then I write the last equation on the following page is that we need to apply summation of forces equal to 0, let's say on that direction. So this will give you what? This will give you 12 plus 12, so we'll give you U1. Let's do 12 Q1 plus 12 Q2 plus 12 Q1 plus 3 times 12 Q sub naught equal to 0. Okay? So from that flange, we can get the first equation. We're going to get the first equation that we're going to have 24 Q1 plus 12 Q2 will be equal to minus 36 Q sub naught. Or if we can simplify this by what? This will be equal to 2Q1 if we divide by 12 plus Q2 will be equal to minus 3 Q sub naught. So remember over here that we are assuming that Q sub naught is known. So Q sub naught is not an unknown. So unknowns over here, Q1 and Q2. Okay? And really the three unknowns we need to find are Q1, Q2, and Q3. So now next, we can go to another stiffener. So let's say we go to this one, 5, 6, 7, 8. So now we move to a stiffener. Five, 6, 7, 8. 5, 6, 7, 8. Okay, and if I do a similar figure, it would be 5, 6, 7, 8. So it will be. Alright, if we look at the figure over here, what are you gonna have? You're gonna have on top, you're gonna have Q1. Okay, I'm looking at this figure. Okay, so it will be Q1 left. Oops, yeah, I forgot to put this. Q1 left. And in the middle panel, we're gonna have Q2 left. Okay, and now what are you gonna have on this one? This one will be 0. So 0 over here. And then the other one would be Q3 going in the opposite direction. Okay? So now I do, see if I have a different color. I do it in blue, so we're gonna have Q3 over here. Alright, so again we apply the summation of forces equal to 0, and this is going to give us what? Minus 12 Q1 minus 12 Q2 minus 12 Q1 plus 2 times 12 Q3 will be equal to 0. So here we're going to get what? 24 Q1 plus 12 Q2 would be equal to 24 Q3. So we can find a second equation relating Q1, Q2, and Q3. That would be 2Q1 plus Q2. Oh, maybe I should have left that one, minus 2Q3 equal to 0. And this will be our equation 2. Okay, so now we have another unknown, which is Q3. So that means that we need to find a third equation in order to solve, because Q sub naught here, remember, is known, so that's not an unknown. Okay, and last we can take the stiffener. So let's see which one we could take. Let's take now this one here, 1, 5, 9, 13. 1, 5, 9, 13. Okay, so this one is going that direction. So 1, 5, 9, 13. Okay, so let's see what we have. We have Q sub 1, Q sub 1, Q sub 1, and here we're going to have Q sub 3. And on each one of the other sides, we're going to have, going up or down, it's going down, so we're going to have Q sub naught, Q sub naught, and Q sub naught. Okay, so now let's say we do summation of forces in that direction. So what do we get? So let's do everything positive or negative, it doesn't matter. Let's do minus 12 Q1, minus 12 Q3, minus 12 Q1, minus 3 times, oops, we need to be careful here, because if I remember right, those lengths are not the same. If you remember, this is 5, 7, 5, okay? So it's nothing to 12 over here, so sorry for that. So that distance over here is so here is 5, and this is 5 as well, and this one over here is 12. So I wasn't paying attention, so sorry for that. So maybe I still do it here, so that we have the figure. So what you're gonna have, this will be equal to minus 5 Q1 minus 7 Q3 minus 5 Q1. This will be now 5, 5, and 7. Okay, so 5, 5, and 7. Would be minus 17 q sub naught equal to 0. Okay. So from here we're going to get the equation. We get minus 10q1 minus 7q3 equal to 17q sub naught. Okay, and we cannot simplify this one more, so this will be our equation 3. So the next step now will be to solve the 3 equations, okay, with 3 unknowns. So let's see what is our system. Our equation 1 was 2q1 plus q2 equal to negative 3q sub naught. Equation 2, 2q1 plus q sub 2 minus 2q sub 3 equal to 0. And our last equation is minus 10q1 minus 7q3 to be equal to 17q sub naught. Okay, so I'm going to pause the video for a second just to solve this system, okay? And I will give you the result. Okay, so in order to solve this system, you can do it by hand, but I decided to go to Maple, and let's check the equation. 2q1 plus q2 plus 3q sub naught. 2q1 plus q2 minus 2q sub 3 minus 10q sub 1 minus 7q sub 3. And I move this one minus 17. So when you solve, you can see that we're going to get q sub 1 equal to minus 13 over 20 q sub naught, q sub 2 to be equal to minus 17 over 10 q sub naught, and q sub 3 equal to minus 3 over 2 q sub naught. So let me show you that. Let's see, what do I need to do over here? So I had the camera open, maybe not. Oh, okay, now I know what happened. Sorry for that. Let me close this. All right, there we go. All right, so basically we have over here, so maybe I want you to notice something. So let's see, we have over here that from here you can notice that q sub 1 is 13 over 20, so that means that it's lower than 1, so it's really lower than q sub naught. In this case, just look at the magnitude, because the sign it just gives you a direction. Q sub 2 is 17 over 10, so it's higher than q sub naught, and q sub 3 is 1.5, is also higher than q sub naught. So if we go back to our figure, over here, we can maybe do the following observation, which is good to check, is that the panels having an edge in common with the cutout, which basically is what is Q2 and Q3, okay, have higher shear flows, and Q1, these four panels which don't really have an edge, they have a corner but not an edge, will have a lower shear flow than Q sub naught, okay? So let's write down that observation. So let's over here, note. Or observation will be what? Is that panels / webs having an edge in common with cutout have a higher shear flow. So that basically means that Q2 is higher than Q naught and Q3 is higher than Q naught. And the other observation is that shear flow, or shear flows, because it's four of them, in panels, webs, shear flow in panels, webs on corners of cutout have a smaller shear flow. Okay, which in our case over here is Q sub 1 lower than Q sub naught. Okay. All right, so remember here's a negative sign, so we need to be careful when we do now the calculation for the actual load. So part 3 was to calculate the actual load. So let me go to the next page. Okay, page 43. So 3 will be actual loads on flanges and stiffeners. Okay, so this is pretty simple. Let's just go to the top flange. So let's see what we have on the top flange. Our top flange is 1, 2, 3, 4, okay, in which we have P1, P2 is the one in compressions. We have 1, 2, 3, 4, okay. So what do we have? We're gonna have Q1, Q2, Q1. Okay. So I'm just going to use a color from now on. So what is Q1? Q1 we just calculated would be equal. So we say what's going to the right. So really we know basically all these need to counter-react this Q sub naught. Okay. So this actually needs to go on the opposite direction. So Q1 should actually be going to the left. That's why we have negative sign. So this one and this one should be the same. Okay. And we'll calculate that Q1 is equal to 13 over 20 Q sub naught. So 13 over 20 Q sub naught. 13 over 20 Q sub naught. And now the middle one is Q sub 2. Now we find Q sub 2 also to be negative, but 17 over 10. And this will be now 17 over 10 Q sub naught. Okay? All right. And here what will happen is that you will see that at this point over here, okay, the load is not the same one, so it should be here a discontinuity on the loading. Okay, so you saw the error message, so I had to go down to this, so we can go here now to the lower flange, which is 13, 14, 15. I mean, but you see now what needs to be done is all the time the same, 13, 14, 15, 16. So what do we have over here? We have Q sub 1 going to the left. So now they're going to go to the right. Okay, and Q sub 1 is equal to 13 over 20. Q sub naught, 13 over 20 Q sub naught. The middle one will be, so basically it should be the opposite than this one. So it should be here, should be Q sub 2. Going to the left, so it's going to the right. Okay, and Q sub 2 should be 17 over 10. Yeah, 17 over 10 Q sub naught. So basically just the opposite of the one we had at the top. And again, here should be also a discontinuity. Here should be also discontinuity, discontinuity, discontinuity. Same thing over here. Okay. Discontinuity, discontinuity. So discontinuity. Here the same thing. Okay, discontinuity. Need to add those points, and here will be discontinuity. Okay. So now we can keep doing the same thing. Let's say now we're going to look at the, let's just do one more, okay? Let's just look now at the stiffener, the stiffener here, and I will stop over here, okay? You can redo all of them, but this will be almost everything. Let's just do now one of the verticals. So let's say we're going to over here. Two, 6, 10, 14. So I'm doing this one. So we have this one is going up, so it should be going down. So we have down on that side, and we know that Q sub 1 is 13 over 20 Q sub naught. 13 over 20 Q sub naught. Then we have on that side, we're going to have Q sub 3 going up, so it's going to go down. Q sub 3 is equal to 3.5 Q sub naught. Now on this side, we're going to have Q2 that is going down, so it should be going up. So this will be 0. Here we're going to have Q sub 2. Q sub 2, which is equal to 17 over 10 Q sub 0, 17 over 10 Q sub 0, and again at those 2 points over here, you will have a discontinuity. Okay, so really if we want, we can do the same thing now for what? 2, 6, 9, 10, we can do 3, 7, 11, 15. We could even do this one. So here 4, 8, 12, 16, and 1, 5, 9, 13, okay? But we'd just be repeating too much the same problem over and over and over. Maybe what I can do just for one of the stiffeners, let's say for this one, okay? Let's just do the plot for this one. So let's go here as an axial load distribution. Let us assume, let's say Q sub naught equal to 1, okay? This would be LP per inch, okay? So then, what would that mean? Okay. So we do this one here, we'll have 2, 6, 10, 14. On this section, what will we have? Let's say positive, we'll have so 13, so minus, so 17 over 10. So multiply this by what? 2 will be 34, minus 13 would be 21. Over 20, okay? So this should be over here. So let's see which one was bigger, 17 over 10. So 34. 34, 24, 21. So this one basically is going up to a value of 21 over 20. This section, then over here we have 0. This one would be going down to 3.5, and then this one would be basically the same thing, would be 21 over 20. So